Dynamic CMOS circuit techniques. CMOS transmission gate logic. The basic two-phase synchronous logic circuit principle in which all individual logic blocks are cascaded via clock-controlled switches can easily be adopted to CMOS structures as well. Here, static CMOS gates are used for implementing the logic blocks, and CMOS transmission gates are used for transferring the output levels of one stage to the inputs of the next stage. Notice that each transmission gate is usually controlled by the clock signal and its complement. As a result, two-phase clocking in CMOS transmission gate logic requires that a total of 4 signals are generated and routed throughout the circuit. As in the NMOS based dynamic circuit structures, the operation of CMOS dynamic logic relies on charge storage in the parasitic input capacitance during the inactive clock cycles. To illustrate the basic operation principles, the fundamental building block of a dynamic CMOS transmission gate shift register is shown in figure. It consists of a CMOS inverter which is driven by a CMOS transmission gate. During the active clock phase Ck equal to 1, the input voltage Vin is transferred onto the parasitic input capacitance Cx via the transmission gate. Note that the low on resistance of the CMOS transmission gate usually results in a smaller transfer time compared to those for NMOS only switches. Also, there is no threshold voltage drop across the CMOS transmission gate. When the clock signal becomes inactive, the CMOS transmission gate turns off, and the voltage level across CS can be preserved until the next cycle. Figure shows a single phase CMOS shift register which is built by cascading identical units in figure, and by driving each stage alternatively with the clock signal and its complement. Ideally, the transmission gates of the odd number stages would conduct during the active clock phase when Ck equal to 1, while the transmission gates of the odd numbered stages are off, so that the cascaded inverter stages in the chain are alternately isolated. This would ensure that inputs are permitted in alternating half. Here you can see the figure, typical example of dynamic CMOS. Dynamic CMOS transmission gate logic. Here you can see the figure, basic building block of CMOS transmission gate and the dynamic shift register. Here you can see the figure, single phase CMOS transmission gate, the dynamic shift register. Here you can see the figure, the dynamic CMOS logic gate implementing a complex Boolean function. Cycles in practice, however, the clock signal and its complement do not constitute a truly non-overlapping signal pair. Since the clock voltage waveform has finite rise and fall times, also the clock skew between Ck and Ck dash may be unavoidable because one of the signals is generated by inverting the other. Therefore, the two-phase clocking with two non-overlapping clock signals phi 1 and phi 2 and their complements is usually preferred over single phase clocking in dynamic CMOS transmission gate logic. Thank you.